countermeasure wherein this will be launched and the incoming missile will be destroyed. So that is the thing. So fine. Now this is how this one. So you have what is known as a Patriot missile system. So wherein this control system is connected to the defense forces, their counter missile systems, and that will be launched. The same thing they are doing even in for the Navy. So these are the kind of technological advancements which are happening in the defense forces. Suppose now in a navies you have some 4 or 5 ships going. You have an aircraft carrier in between. This is your aircraft carrier. There's one more destroyer. There's one more destroyer. So 3 ships are going as a part of a group. Aircraft carriers usually do not have a missile guns to protect themselves. So if there is any incoming missile coming, these 3 will have antennas. These 3 antennas will be part of a group, and any incoming missile coming, what happens is any of these or 3 of these will launch countermeasure missile, like your for example your what to say, your BrahMos missile that will be launched, and this will be destroyed. So 3 missiles will be launched. If one misses, second will hit. If second misses, third will hit. So these kind of missile system software development is very complex, and if you are able to do this, you will be multi-millionaire. You got my point. All the systems right now are supplied by Israel for our Indian Navy. You got my point, all of you?
Yes.
Okay. So what I suggest, Bina, those who are not able to join the classes physically, anyway, I'm uploading that in the YouTube and this one. So that list, please send it to Dr. Srinivas Rao. Those who are not able to join due to genuine reasons. From B section, Saurabh Bhatt can send, and from A section, Bina can send. So such attendance will be considered.
Yes, sir.
Okay, sir.
So that solves the problem right now for this class. Okay, so that is fine.
Yes, sir.
Yes,
so
sir.
you just find the list of students who are not able to join genuinely. So you send that list. So that will be considered for that. Next, we consider what is known as an array of 2-point sources. Okay. Array of 2-point sources. This is your next heading. Please write down. Array of 2-point sources is nothing but array of isotropic radiator for the greater number of point sources. Analysis is complex. Analysis is complex. Okay. In this array of point sources, your first mathematical derivation is case 1, 2-point sources with current equal in magnitude and face. All of you are able to see?
Yes,
Yes,
sir.
sir.
Okay. Consider
Yes, sir.
two point sources A1 and A2. Consider 2 point sources. I'll just draw the diagram. This is your point source A1. This is your point source A2. Okay. They are separated by a distance D. Okay. So these are separated. This distance is D. Are you able to see? All of you are able to see?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Very good. Okay. Okay. Draw two perpendicular lines from this. These are nothing but 1 minute. Something okay. Hmm? Suppose this angle is phi. This angle is phi. What will be this distance now? Sorry. This distance will be d cos phi. Agreed? All of you. All of you agreed?
Yes, sir.
Ah. So what will be that distance? What I have written is correct. That will be d cos phi.
Yes, sir.
Ah, okay. This distance will be your d cos phi. If this distance is your d, all of you are able to see?
Yes, sir.
Fine. Okay. Call this distance as r1 and call this distance as r2. Okay. This is to infinity here. This is to infinity, and this is also to infinity. Okay. This is your perpendicular angle here, so that you have to draw properly. This is your perpendicular angle. So this is your point source. So continue writing. All of you have taken down this figure.
Yes, sir.
Very good. Consider 2
Yes,
point
sir.
sources A1 and A2 separated by a distance d as shown in the figure, Continue. Both point sources are supplied with currents equal in magnitude and phase. Is it clear? Is it clear so far?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Now we'll do one more thing. Consider point P. This is your point P, somewhere away from this diagram. Okay, I have you written down that point P.
Yes, sir.
Yes, sir.
Okay. And phase. Okay, I'll write below this. Consider point P. P for Peter. Okay. Point P far away, FAR, far away from the array, okay. The distance between point P and point sources is R1 and R2 such that R1 is approximately equal to R2 is greater than equal to D. Okay. You got my point. R1, this distance R1 is the distance from point source A2 to point P. R1 is the distance between point source A1 to what? All of you are listening?
Yes, sir.
Infinity.
Yes, sir.
Yes, correct. See, now I will try to demonstrate here. Please see. All of you are able to see my face, right? I am visible to all.
Yes, sir.
Yes,
Okay, very good. So now just to see here, this is one plane I am having. This is one. Okay, like this I will show you. I think you can see now. You are able to see this slate, right?
Yes, sir.
So
Yes,
this
sir.
is one point source here. This is one point source here. You got my point. These are 2 point sources. Suppose the distance of separation between them is 10 centimeters. Assume. You got me point source A1 here, point source A2 here. The distance between their separation is 10 centimeters. Okay. Now I have one point source right on top. Okay, sorry. As an observer, I'm seeing from the top. So from this point to this point, which is at a very far distance, suppose at infinity. So this distance is R1, and from this point to this point, another again at almost infinity, this distance is your R2. This point P is almost very far off from point A1 and A2. You got my point?
Yes, sir.
So
Yes,
this
sir.
is your distance R1, this is your distance R2. Understood?
Yes, sir.
Yes, sir.
Okay, the distance between these points was A1 and A2 is your distance D. Okay, so your R1 and R2 are approximately equal to each other, but far, far greater than your distance D. Is it clear?
Yes, sir.
Yes, sir.
Yes,
Very
sir.
good. Thank you. So this is what I want to tell you. See if it is clear. Again, this particular unit will be very easy for you. Write down the path difference. The path difference arising is d cos phi in terms of the path difference is arising is d cos phi. Please remember this term is known as your path difference, d cos phi. What is the d cos phi? This from point A2 to point P, the distance I will be covering after d cos phi because of this path difference which is happening. You got my point? So that is your d cos phi. This is the extra length traveled by A1, right? As compared to A2. So signal from one of the point sources will arrive at a time interval after d cos phi. That is what I want to tell. Is it clear, Saurav? Am I clear?
Yes, sir. You're clear, sir. I'm understanding.
Okay, very good. Bina, am I clear?
Yes, sir.
So these are very important concepts. So that's why I'm telling you to listen very carefully. In terms of wavelength, path difference is given by d cos phi by lambda, where lambda is equal to wavelength. Got my point? Lambda is your wavelength, path difference in terms of lambda. Okay. Now, we define phase angle psi is equal to 2 pi into path difference So, but any limit on the time at 11 o'clock, will it cut off?
No, no, sir. No limit on the time. Only limit on the total participants.
Okay, so I have one solution for this. Let me discuss after the class. So let us finish this. So what is the path difference now? 2 pi into Mahima, tell me d. What I should write? Path difference is equal to d cos phi by
Lambda.
Very good. Fine. So I can rewrite this as psi is equal to 2 pi by lambda. We'll call this as equation number. So I assume this as equation 1 in terms of lambda path difference is this. Your phase angle psi, I will call this as equation 2. and same thing 2 pi by lambda into d cos phi. Okay. Now we define propagation constant beta is equal to 2 pi by lambda. Path difference beta is equal to 2 pi by lambda. So what happens? Your phase angle psi becomes equal to beta into d cos phi, where beta is equal to this will be your equation number 3, where beta is equal to your 2 pi by lambda. Beta is equal to your 2 pi by lambda. This is known as your propagation constant. This is very important even in our photonics. Okay. Now what we will do is we'll find the total electric field due to the 2 point sources applied with current equal magnitude and phase difference. So I am finding the total electric field at point P due to these 2 point sources applied with currents equal magnitude and phase difference. So what I am going to do is now I am going to find the electric field at point P. Okay, I am going to find the electric field E at point P due to 2 point sources, 2 point sources supplied with current equal in magnitude, and phase with origin taken as point source A1, with origin taken as point source A1. Got my point? So this is what we are going to do is find the electric field due to these 2 point sources supplied with currents equal magnitude and equal phase, wherein the what to say, your origin is taken as point source A1. Okay. Okay. Origin means, now what I am going to do is, this is what is one of the questions. You have origin at, this is your point source A1, this is at your point source A2, this is your point P, where I have to find the electric field due to these two combined effect of these 2 point sources. This distance between these 2 point sources is your distance D. So I can take the origin right at the center, that is my reference point, or I can take the origin here. So right now for this question, I am considering the origin at as the point source 1 itself. So this I am considering this as your origin, and both point sources are supplied with currents equal magnitude and equal phase, not opposite phase. So these are the different derivations that will be asked in your university. You have to read the question very carefully before answering. Whether the electric field is to be found with 2 point sources supplied with currents equal magnitude in phase or equal magnitude opposite phase. So that is very important to be noticed before you start doing the problem. Is it clear?
Yes,
Yes,
sir.
sir.
Okay. So where are we considering the origin now?
Exactly in between the 2 points.
No, I am not considering the in between now. I am considering the origin as the point source A1. Please remember,
Yes,
this is the first derivation I am doing. So next I will be doing right at the center. So right now I am considering the origin as the point source A1. So this is the origin I am considering. So this drawing here, so this is the origin point I am considering now. This is the origin I am considering. Next I will consider origin at the center. You got my point?
Yes, sir.
Ah. So this is the simplest of all the derivations. So we will start with this. All you have mathematics, so your concentration and your attention is of utmost importance now. Please sit in front of your systems or mobile phones wherever you are. Listen as much as possible, and in the YouTube videos which I upload, you can also see that. Okay. Now your total electric field E is due to electric field due to point source A1 plus point source A2. This is your total electric field. So what was my previous equation number 3? So this equation number will be 4. See, if this question is asked, you have to start right from here. Right from this figure you have to start. So I am only doing electric field now. So don't start from this point now, from equation 4. You have to start all the way from equation 1 for your examination point of view. Is it clear?
Yes, sir.
Okay. So since A1 is the origin, since the point source A1 is the origin, so this electric field I will consider as E naught, because that is the origin itself. Your E2 will become E naught into E raised to the power J psi. What is your psi? Phase angle. Beta d cos phi. That is your E raised to the power J psi. Psi term will come here because this is your phase difference which is coming in your point source A2 due to A1. If that A1 is not there, your E2 will also be E naught. Okay, since this is there, you are getting your E raised to the power J psi term. So suppose I consider this as your origin. Suppose I consider point source A2 as the origin, what will happen now? If A2 was the origin, what will happen to the equation?
E0 into e power j psi plus E naught.
Pardon? If A2 were the origin instead of A1, what happens to the equation? This equation, what happens? Saurabh, what can you answer?
Sir, instead of like the E2 bar will become E naught into E power J.
Yes. So if A2 were the origin, so what will happen is you will have E naught E raised to the power J psi plus E naught. Nothing will difference. So here instead of E1, it will be E naught E raised to the power J psi because this is your origin point. So where you are considering the origin is very important. Where is my reference point? That reference point will not have any phase difference because that is the point of reference. That is the point of starting. Whichever is the other point will have the phase difference. Is it clear?
Yes, sir.
Yes, sir.
Okay, very good. Purva Chandra Prakash, is it clear?
Yes, sir.
Very good. Thank you. Beena, is it clear?
Yes, sir.
Too much concentration is required here. See, once you understand, you will understand. If you don't understand, you don't understand. It is one like binary here, 1 or 0. It is not like partially you understand, partially you don't understand. So I can rewrite this equation as E naught 1 plus E raised to the power J psi. Is it correct? Okay. Now I'll rewrite this, I will rewrite this above equation as 2 E naught multiply and divide by 2 E naught. I will take E raised to the power J psi by 2 outside the bracket. So what I will get the first term? E raised to the power minus J psi by 2 plus e raised to the power j psi by 2. Is it clear? Correct? Have I changed anything in the equation?
No, sir, nothing has changed.
Say I am multiplying dividing by 2 here, multiply and divide by 2, and I take e raised to the power j psi by 2 outside. So inside the bracket you will get e raised to the power minus j psi by 2 plus e raised to the power j psi by 2. If you multiply this, you get back the same answer. J psi by 2 into minus j psi by 2, you will get 1. E raised to the power j psi by 2 plus e raised to the power j psi by 2, you will get e raised to the power j psi. You got my point?
Yes, sir.
Yes,
Okay.
sir.
So E is equal to 2 E naught e raised to the power j psi by 2. What is this term? This whole term, what is going to this become?
Cos 5
Excellent. Excellent. Congratulations, whoever has told that answer. Cos psi by 2. Okay. This, 1 minute. This 2 E naught is nothing but your amplitude part. This is your amplitude part. So I can set, this is your electric field E. So set 2 E naught is equal to 1. That is the maximum value it can take. That is your 1. So your electric field E can be written as e raised to the power j psi by 2 into cos psi by 2. Okay. So this what is this equation number will be 5. This equation number will be 5. So I can also write as electric field E is equal to cos psi by 2 at an angle psi by 2. This is your another thing. So this is your result when you consider A1 as the point of origin. Is this equation correct, Saurabh Bhatt?
Yes, sir, it is correct.
Very good. Since all of you agree with me, write down the above equation. The above equation is the amplitude variation of E, variation of electric field E. Okay, and the angle part represents phase variation with respect to force 1, which acts as reference reference. Okay. If D is equal to lambda by 2, then your phase diagram will be like this. This is just the vector diagram I'm trying to draw here. This is how it is resolved. So this your entire angle is psi by 2. If your entire angle is psi, so what will be this angle? This will be your psi by 2 and this angle will be your psi by 2. Agreed?
Yes, sir.
Okay. So this is your first source. E1 is equal to E0. This is from your source 1. This is from your source 1 which you are taking as reference, and this will be your E2. This particular thing will be your E2. This will be your E2. That will be equal to E0 into e raised to the power j psi by. This will be your e raised to the power j psi by 2. Okay, this is from your source 2. Is it clear?
Yes, sir.
This is your source 1. This is your source 2. So this is your resultant electric field E. Is it clear? This is your resultant electric field E. Sir, are you able to appreciate this vector diagram?
Sir, excuse me, sir. Sir, E2 is equals to E0 into E power J5, no, sir. J5 by 2.
It is j psi, correct. E raised to the power. Correct. That is e raised to the power j psi. Correct. So you are right. This 2 is not there. 1 minute, I will drop this. Okay. This half angle is your psi by 2. So when you are taking respect to source 1, if that is the reference, that will be your psi by 2. If you are taking midway as the reference, then you will get here psi by 2 and here one more psi by 2. That is that will be the next thing we'll be doing. Yes, you are correct. All of you are clear with this derivation?
Yes, sir.
Yes, sir.
Yes, sir.
Very good. Are you having the strength to continue for 10 more minutes? Tell something, no? Saurabh, but shall I continue?
Okay, sir.
Yes, Poro Chandra Prakash, shall I continue? I am in full Zoom room.
Yes, sir.
Oh, okay. Dina, shall I continue? 10 more minutes. You
Yes,
get
sir.
appropriate break, don't worry. So if I were to stop here, there will be something which is unfinished. Okay, next you write down 2-point sources. 2-point sources supplied with currents equal in magnitude and phase with reference point at the center of the array. Center of the array. Okay. The same derivation. Now what I am doing, Purvi Chandra Prakash, 2-point sources A1 and A2. 2-point sources A1 and A2. So where I am getting, where I am taking the origin.
Center.
Very good. So this point I'm taking the origin. So right at the center. So what will be if this whole distance is d? This is your d by 2 distance. Agreed? Exactly at the center.
Yes,
I'm
sir.
taking. Now you will. So this is my reference point. So this from this reference point, your distance to point B also have to measure now. That is your my reference point. So if this angle is psi, this angle also will be psi. So once again, we'll start. Your total electric field will be equal to E1 plus electric field E2. Now this will be E0 e raised to the power j psi by 2, because this is the origin. From with respect to this, phase difference will be your psi by 2 because it is at the half distance. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Plus E naught. Now see very carefully. This will be e raised to the power minus j psi by 2. Okay. See, one direction I am taking positive, one direction I am taking negative. You understood?
Yes, sir.
This center point is your zero reference point. So one side negative, one side positive you have to take. So this side if I take positive, that side will be negative. This side if I take negative, that side will be positive. Understood? With respect to origin, why this is minus? Is it clear?
Yes, sir.
Yes, sir.
Please yes or no, otherwise I am ready to repeat 101 times. This concept is very important. So origin I take at the center. If I take origin at the center, you will get a phase shift here. Okay, listen here. Okay. If I take the origin at the center, here you will get a psi by 2 phase shift here, psi by 2 phase shift this side. Okay. So one you take as positive, one you take as negative. Understood?
Yes, sir.
Okay. Another one important mathematically, if you take that as the origin, one will be positive, one will be negative. That is insofar as the mathematics is concerned. Insofar as our electromagnetics is concerned, the technical difference is psi by 2 is the wave leaving the point, minus psi by 2 is the wave approaching the point. That means this A1 is acting as a transmitting antenna. Your wave is going away from A1. You understood? This wave here is traveling away from point source A1. This wave is going towards the point source A2. You got it? Here is the electromagnetic wave coming towards A2. This one is going, sorry. This one is going away from A1. That is why it is positive, this is negative. This will act as a receiving antenna, this will act as transmitting antenna as per this mathematics. So there are two ways of looking at it, mathematically and in terms of your antenna theory. Okay. Yes or no?
Yes,
Yes,
sir.
sir.
Okay. So what I will, sorry. Mahima, did you understand?
I understood, sir.
What I will do is, Sangeeta, did you understand? Sangeeta, are you there? Okay.
Yes, sir.
Did you understand, Ma?
Yes, sir.
Thank you. Okay, so this is how the equation will be rewritten. Once again,
Yes, sir.
multiply. Very good. Multiply and divide by 2. So what happens is this will be 2 E naught e raised to the power j psi by 2 plus e raised to the power minus j psi by 2 divided by 2. Okay. So this will be nothing but this is your total electric field E. So your total electric field E will be nothing but 2 E naught. This will be your cos psi by 2. So I will make 2 E naught is equal to what I should make 2 E naught is equal to
Beta.
beta. Huh?
1.
Correct. This is nothing but your amplitude part. So your 2 E naught I will make equal to 1 set E. This is your amplitude part. Set 2 E naught is equal to 1. So your total electric field E is equal to only cos psi by 2. Okay. Is it clear?
Yes, sir.
All of you? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Now, what is the significance of these two derivations? If you take the origin as the point source A1, then you will get an extra angle psi by 2 here. Can you see this phase shift?
Yes, sir.
Okay. Here you don't get this extra angle phi by 2. It is just cos psi by 2. Okay, actually this represents your phase difference also. In this case, what happens is your where is that figure? Okay. So in this case, the first case we are taking this as origin. What happens is this has a one phase shift with respect to this one. Apart from this point source P, which will have a phase shift while you are receiving the signals. So this has with respect to that. That is also coming in your derivation. If you take this as origin, you are negating these two phase shift because you are taking the origin right at the center. Is it clear? So two
Yes, sir.
we have considered. If you take the origin point as A1, you will get the phase shift of A2 with respect to A1. That is why you will get at point P cos psi by 2 at an angle psi by 2. That angle psi by 2 is this phase rotation of A2 with respect to A1. Whereas in your second case of derivation, when I am taking the origin right at the center, these two phase shift are getting negated because the origin is right at the center. You will get here cos psi by 2, cos psi by 2. Directly you will get here cos psi by 2. That angle psi by 2 you are not getting if you are considering the reference point at the center of the array. You understood all this mathematics will go in a long way in designing your array of point sources. This is only 2 point sources. There are n point sources. What happens also we will see. This is current supplied with equal magnitude and phase. Next we will see equal magnitude opposite phase. Before that we have to see where is the maxima direction and the minima direction. Can I continue or you will want me to stop here? Beena, shall I continue?
Okay, sir. Like another 5-10 minutes, you can continue.
I'm in full Zoom today, so I wanted to do as much. Purva Chandra Prakash, shall I continue?
Yes, sir.
Very good. So all of you are Wing Commander Srinivas Rao, another 5 minutes I will continue, then we will give them a break.
Okay, please go ahead. No issue.
I am in some kind of full into to do. That's why I don't want to stop here. So,
Yeah. I can see that. Very nice, actually.
so maxima direction for the above equation will do where we will consider the center at the reference point at the origin. So if you consider reference point at the origin, you will not get that angle psi by 2. So what will happen is cos of psi by 2 for maxima direction equate it to plus minus 1. Is it clear? Equate for maxima direction cos psi by 2 is equal to plus minus 1. So what happens is cos of Psi is what? Beta d cos phi. That is your phase angle. Beta d cos phi. Just now we have derived. Psi is equal to beta d cos phi. Mahima, is it clear?
Yes, sir.
Beta d cos phi. This is your psi. This whole thing is beta. So psi is your beta d cos phi. Don't forget for the rest of the semester. You forget you are eating. Don't forget this. Psi is equal to beta d cos phi. Psi is equal to beta d cos phi. Remember that. Okay. So psi by 2 is beta d cos phi by 2. That is equal to your plus minus 1. Okay. Assuming this, write down. Assuming d is equal to lambda by 2. Assume d space d distance between the 2 point sources as lambda by 2. So what happens? Cos of beta d is your lambda by 2. Lambda by 2 cos phi. Lambda by 2 cos phi by 2 equal to plus minus 1. Okay. This is your beta is lambda by 2 cos phi by 2 is equal to plus minus 1. So next, cos of beta is equal to 2 pi by lambda, right? So 2 pi by lambda, that is your beta is equal to your 2 pi by lambda. Am I right?
Yes, sir.
Okay, into lambda by 2. So lambda gets cancelled, 2 get cancelled. Pi cos phi. Okay, this divided by 2. This is equal to your plus minus 1. Okay, so finally what you get, cos of, this is your maxima direction I'm telling, cos of pi by 2 cos phi, pi by 2 cos phi is equal to plus minus 1 for maxima direction. That is, this is all mathematics. Pi by 2 cos phi max, this is for maxima direction, is equal to cos inverse. This cos is going that side. Cos inverse of plus minus 1. This can be equated to plus minus n pi, where n is any integer. When n is any integer, you can have value 0, 1, 2, 3, 4, so on and so forth for value of n. Assume now for your case where if n is equal to 0, what you will have is pi by 2 cos of phi maximum is equated to 0 if n is equal to 0. Agreed?
Yes, sir.
Cos of phi max will be equal to what? Purva Chandra Prakash. Cos of phi max will be equal to
0.
Narayana N. Are you there?
Yes, sir.
What will be phi max now?
1, sir.
1.
1,
In terms
90
of degree,
degrees.
90 degrees, sir.
90 degree or 270 degrees. Write down. 90 degree or 270 degrees. Degree or 270 degrees. This is your maxima direction. All of you got what is maxima now?
Yes, sir.
Now go to minima direction. Minima. All these are mathematics, so I'm not spending that much time in explaining that. The concepts are very important. Next, minima direction, cos of psi by 2, I will equate to what? I should equate to minima means
0.
Very good. 0. Anda. Okay. Murgi ka anda. Okay. Equate to 0. Anyone took anda today? Okay. So if you have not taken, I can't help. Okay. Cos of psi is equal to your beta d cos phi by 2 is equal to 0. Okay. Now substitute d is equal to lambda by 2 and beta is equal to 2 pi by lambda. Okay. So if you substitute that, so same thing you will get cos of pi by 2 cos phi minimum is equal to 0. Agreed? Phi max, instead of phi max, I am writing as phi minimum because this is your minima direction. Cos of pi by 2, cos of pi by 2, cos phi minimum is equal to 0. Got it?
Yes, sir.
So what will happen now? Pi by 2 cos phi minimum will be equal to your cos inverse of 0. Okay, actually this you have to equate to 2n plus 1, 2n plus 1 into pi by 2. Substitute n is equal to 0. Substitute n is equal to 0. This is all mathematical things. I will not go further into this. So what will happen here? Pi by 2 cos of phi minimum is equal to pi, here you will get here. So this is plus minus 0. Sorry. Actually, you should write here plus minus. So this will be cos inverse of plus minus. So again, you will get here plus minus. So actually, you can't write plus minus 0. There it is plus minus. Therefore, for your understanding, I am writing plus minus pi by 2. So what happens? Your pi by 2 will get cancelled. So your cos phi minimum is equal to plus minus 1. Plus minus 1. So what will be your phi minimum, Mahima?
Sir, 0.
What will be phi minimum?
0 or 180 degrees.
Excellent. Who is answered that?
0 or 180 degrees, sir.
Very good, Rainak Sharma. Did I get your name right? Very good. So this is your minima direction. Next we will do what is known as a half power power direction. Half power direction. This is known as your HLR, half power point direction, that is known as your HPPD, half power point direction. Half power point direction. So half power point direction is nothing but the power or the voltage becomes 1 by 2 of its maximum value is equal to 1 by 2 of its maximum value. That is, your electric field will be 1 by root 2 of its maximum value and your power will be 1 by 2 of its maximum value. Since E is equal to cos phi psi by 2, that is your 1 by root 2 of your maximum value. So I will rewrite this equation as cos of what? Psi by 2 is equal to plus minus 1 upon root 2. This is your half power point direction, 1 upon root 2. Substitute psi is equal to beta d cos phi. Substitute psi is equal to beta d cos phi. Substitute d is equal to lambda by 2 and substitute beta is equal to 2 pi by lambda. So what you will end up getting is cos of pi by 2 cos phi half power point direction HPPD is equal to plus minus 1 upon root 2. Plus minus 1 upon root 2. Okay. So this will be pi by 2 cos of phi half power point direction HPPD is equal to cos inverse of plus minus 1 upon root 2 is not, this can be equated to plus minus 2n plus 1 into pi by 4. Substitute n is equal to 0. Then what you will end up getting is pi by 2 cos of phi of half power point direction is equal to plus minus pi by 2. Is it correct? Sorry, pi by 4, no? Plus minus pi by 4. Substitute n is equal to 0, then you will end up getting plus minus pi by 4, right? Are you there?
Yes, sir.
This will be
Yes, sir.
plus minus. What will be this? Pi will get cancelled. So this will be 2 1s are. This will be 2 2s are. So this will be 1 upon half. This will be half. So your angle phi of half power point direction will be cos inverse of plus minus 1 half. That will be, so what will be half your HPPD direction? 60 degrees or 120 degrees. You got my point?
Yes, sir.
Finally, we'll draw the shape
Yes,
of the curve what we will get for the things supplied with currents equal in magnitude and equal in phase. So this is the plot you will end up getting. I'll try to draw this. I don't know how successful or I'm unsuccessful I am in drawing this shape. So your maximum direction is 0 and 90 and 270 degrees, right? So you will have a plot like this. Nice 8 shape, please draw. Okay. This is your 90 degrees. Sorry. So this is your 90 degrees, 270 degrees. That is the maxima direction. This is your 0 degree. Okay. This is your 180 degree. And this will be your 60 degree. And this will be your 120 degrees. You'll be doing problems on this. Therefore, you need to know this. Understood, all of you?
Yes, sir.
Understood how did I draw this plot? No, this is 0 and 180 degrees minima direction or the point of no radiation. That is what we have got in this this one. 0 or 180 degrees phi minimum direction. So this is your phi minimum. This is your phi minimum direction. This is your phi maximum direction. Both your 0 degree, 90 degree and 270 degree is your phi maximum direction. And this is your phi half power point direction. Understood?
Yes, sir.
Very good.
Yes, sir.